am going to be talking about building type-safe GraphQL APIs with Prisma and using a library called Pothos that I've been working on. So what is Pothos? Pothos is a code-first schema building library for GraphQL. If you're familiar with Nexus or Type GraphQL, this might be an alternative to those libraries. If you're not familiar, code-first GraphQL builders are basically a pattern for building GraphQL APIs through code. In this case, it would be TypeScript. And kind of the schema, your GraphQL schema ends up being an artifact that is generated from the kind of the code and the types you define inside of your application, rather than building manually typing out your GraphQL API and then building out resolvers that match the schema you've defined kind of manually somewhere else. One of the big focuses for Pothos is type safety. It has a pretty powerful type system internally that makes it one of the best ways to ensure that your GraphQL APIs are completely type safe. This means that everything from defining types and fields and arguments all the way through resolvers that actually return the data for your application are entirely type safe, and you'll get great autocomplete throughout that whole process. And then one of the big parts of the type safety system is that it is entirely built through using TypeScript features rather than depending on things like code generation or experimental decorators or other metaprogramming techniques that you might have run into if you've built GraphQL APIs with TypeScript in the past. It also has a very extensive plugin ecosystem. So there are plugins for all kinds of things like authorization, validation, data loaders, and of course Prisma, which is kind of why I'm here to talk about this. The plugins for Pothos use a kind of unique pattern that makes the plugins really feel like they're part of the core API, and the plugins can hook into and take advantage of all the same type safety features that exist in the core. And that means things like defining a authorization check or something in your schema. If you have a field or a mutation, you want to perform some kind of authorization logic on that. Those authorization checks will automatically get access to your GraphQL context and your arguments, all with complete type safety without you having to import types from anywhere. And you also don't have to manually specify types anywhere. Throughout this whole presentation, everything will be type safe, though you won't see a single manual type definition anywhere in that process. And this all kind of culminates in what I think is a really great developer experience. You kind of get to build an entire GraphQL API with all the different components, whether that's authorization or the actual code that does resolve the data for those requests in one kind of consistent API, rather than having to define your schema in one file, then to define your resolvers in a separate file, and then authorization checks somewhere else using a different library. This kind of brings all of those pieces into one nice, clean API. So why would you use Pothos? It's designed to work at kind of any scale. This is a project that I started building at Airbnb when we needed to quickly build out a GraphQL API that exposed the majority of Airbnb's data for customer support agents. So Airbnb has a whole lot of different services, and a lot of those services were designed to expose data for the consumer-facing use cases, and we were kind of working on redesigning a lot of the tools for customer support, so we needed to quickly spin up a pretty complicated GraphQL API, and Pothos was part of that solution. It also is used internally at Netflix for a couple of APIs, but it also works great at really small scale. So I use it all the time for prototyping things. It is very fast and easy to set up and just kind of works out of the box without a lot of configuration. And so it's really great at almost any scale you can imagine. It's very flexible and extensible, so you have a plugin system to kind of add your own features. It has a lot of different patterns that it supports for how you can split up how you're building your applications. And then it is designed to work with your data. One of the common pitfalls when building GraphQL APIs is that you will either first design your API and then end up having to basically match your data to the API you've designed, and that can be kind of a painful process. The other way of doing things, which is probably worse, is that you'll build an API around your data and have your API look exactly like the data that you have in your database. This is really great at first, but it doesn't scale well as like your applications change over time. It's really important to be able to kind of have those pieces evolve separately. So Pothos is very intentional about making it easy to build an API manually that kind of works with whatever shape your data is in and ensures that kind of the translation from like the way your data sources to how they're exposed in your API is clean and has good type safety, but doesn't kind of enforce a lot of constraints. And then obviously it works great with the rest of the kind of Node GraphQL ecosystem. So it is completely compatible with things like GraphQL Yoga, Envelop, Apollo Server, or whatever else you might be using today. So I'm going to jump into some code examples. Hopefully these slides are somewhat visible. I know the contrast isn't great, but let's get into it. So on the right, we have kind of a very simple schema that we're defining, and on the left is basically a fully functional GraphQL API built with Pothos. The first thing here on line 4 is you basically create a builder, and then you can start defining types. Here we define the query type, which is kind of one of the main entry points into any GraphQL API. And then we just pass in a fields function that basically just returns the set of fields we want to have available on the query type. Here we're just defining a single string field, hello, defining a string argument, and then a resolver here that returns hello to whatever name is passed in. And as you can see here, we're accessing the name property of arguments, which will be entirely type safe. And you'll get nice autocompletes as you're kind of accessing those properties. And then finally, we call toSchema just to generate kind of a standard schema. This uses the all of the kind of normal modules you get out of the GraphQL.js package. So this will work with Yoga or Apollo Server or kind of anything else. And that's a very quick overview of what it might look like to build a very simple thing with Pothos. But we're at the Prisma Day conference, so I want to try to quickly get into the actual Prisma plugin and what it can do for you. So the goal of the plugin is to make it easy to build with intention. I wanted to talk more about kind of problems with automatically generating your schema, your GraphQL schema from what's in your database. But these talks are fairly short, so I didn't have a whole lot of time to go into that. But the goal is to make it as easy as possible using the data you already have in your Prisma schema to explicitly define an API that kind of you control and design rather than just generating that automatically. So it lets you define types and fields and relations to other types. And then it will help you to optimize the queries that are actually executing and resolving to kind of surface that data to users. So GraphQL APIs tend to get very complicated and interconnected, and there's a lot of different ways a user might be able to query your API, kind of going through various relationships to load data. And manually defining queries that can resolve any query efficiently can be really challenging. So one of the big focuses of the Prisma plugin is making all of those queries as efficient as possible, and will generally result in queries that should be much more efficient than what you could write manually. And obviously, a lot of the easy cases are going to work great, but it also tries to expose some like building blocks so that when those easy cases don't quite work, you could still take advantage of some of these systems and still get great performance out of your Prisma API without having anything get too complicated. And then finally, obviously, this integrates great with the rest of the Pothos ecosystem, so you can still take advantage of all of the like validation and authorization plugins that exist. I'm going to dive into some more code examples here. This is a little bit more complicated and kind of shows how you might define a post type in your in Pothos, or with the Prisma plugin. So the first thing we're doing here is we're creating a new object type in our GraphQL schema for our post model. And then again, we just pass in a fields function that is going to define the fields that are available on that type. Here we're defining ID and title. I don't know if it's obvious what I'm highlighting. Hopefully it's somewhat visible. ID and title are basically just exposing some scalar fields. We use the expose ID and expose string methods here. These expose methods in Pothos are basically just a shorthand for defining a field with a resolver that resolves to like a specific property on the underlying data source. And so it might look like there's a little bit of redundant information in here, but with like the title showing up twice on these lines. The reason we do that in Pothos is pretty intentional. We want to make it always explicit what that you're mapping from one kind of source to another. So on this next line, we have a body field that is exposing the content column from our database. And this is pretty useful because oftentimes you want to be able to change the name of something, and you don't want to tie those things too closely together. The other thing that's interesting here is in our database, we're already defining the type of content column that's going to be a string or some kind of text type. So we could infer that this should be a string in our Prisma schema, or in our GraphQL schema, sorry. But you don't want to be able to change the type in your database and have that automatically reflect the change in your schema. And there's not always a clean mapping of your database types to the types that exist in GraphQL. So a string type might be a string, or it might be an ID in GraphQL, or maybe it's like a custom scalar like an email or something. So in Pothos, you're generally going to always be explicit about the types that a specific field resolves to.
Sorry to interrupt. There is an issue with your mic.
Oh.
I'd like you to just use that one, okay?
Great. Sorry.
Is that okay with the hands?
Yeah. Hope everyone can hear me now. I apologize if you haven't been able to hear me. So the next thing I'm doing here is defining an author field, which is a relation to another model. In this case, it's a user model. And then finally, we have a comments field. And this, if you've ever built a Relay compliant API, defining connections can get pretty complicated. So this is a pretty cool method here that will define a fully Relay compliant connection, which basically is a way to expose like a paginated list of data. And all we're providing here is the ID column, which we're going to use as the cursor when we're doing that pagination. And on the right here, you can see that there's the comments field has the before, after, first, last, kind of normal Relay pagination arguments, and then there's a connection with edges and page info and an edge object and a connection object that all get defined for you automatically. And so all of this kind of shows you how you can define some types and expose some fields, but it doesn't really show you how we are getting data. So the next step is to actually start, is kind of where we get into how we use Prisma to actually start surfacing some of this, or querying this data. And so in this example, we are going to be using the Prisma field method, which basically just lets us create a field that is going to be powered by a query from Prisma. And so again, we're just giving it a type of post because we're going to be exposing a single post, and then defining an ID argument, and then a resolver for that data, for that post, I guess. And so here we use Prisma post find unique, which is just an easy way to get a specific post. And then in our where clause, we pass in the ID that was passed in through the arguments. And then finally, there's this query thing we're spreading here. And this is where the Pothos plugin starts getting pretty interesting. So the query is going to automatically give us either a select or an include that basically defines all of the relationships that were queried by the user. So if the user requested a post and also asked for the author of that post or the comments, the author or the post relation are going to automatically be included as part of this query. So that's kind of what I meant earlier when I mentioned optimized queries. So the way this works is basically that we create this query object and then recursively walk down through the selected fields in our GraphQL selection, in like the incoming GraphQL request, and see what fields were selected, and then map those to relationships that are defined in our Pothos using the Pothos plugin. And then we kind of merge that all down into a single query object that can then be spread into a Prisma query to automatically fetch all of those relationships. If you've ever seen libraries like Prisma Select or Pal.js, this might sound familiar, but this works a little bit differently. There are some fundamental problems with how Prisma Select and Pal.js solve this specific problem, and it doesn't work well with things like aliases or arguments. So when you're selecting these nested relationships and you're either aliasing a field or the relationship, like the comments connection, for example, is paginated, having those arguments as part of your API makes it much harder to figure out exactly how that relationship needs to be resolved. And so that's why this plugin, this kind of deeper integration, is maybe a better solution than some of those libraries that don't have as much understanding of exactly how your schema is built. And so to describe that a little bit further, or give an example of how this can actually play out in practice, I'm defining a user object here that has two fields that use the same relationship. So there's a drafts field and a posts field that are both exposing data that is based on the posts connection in your database schema. So drafts here are going to be passing in a query option where basically we're saying, hey, this is a relation to the ships to the posts, but only the posts where the status of those posts are drafts. And this is kind of powered by Prisma, so all of these types here are kind of match up to the things that are available in your Prisma schema, or when you're using Prisma to query for a post. These all the options here should be fairly similar. And then similarly here for posts, we're defining an argument where we're passing in the status, and then we have these arguments and creating some selection. But this is also a related connection, uses the related connection method, which is going to handle pagination. So on top of the where clause here, we'll also have a cursor and some limit option that will also get added into that query. And so if you're familiar with how Prisma works, you probably know that there's not a way to select the same relationship multiple times in a query today. And so we can't automatically include both the drafts and the posts as things that we're going to query in that optimized query. So in that case, what happens is we first look at the drafts query and include that in the initial query that gets run. And then when we try to resolve the post thing, we know that the posts that were queried are going to be the drafts and not the posts that we're trying to expose here. So rather than trying to just return the data that was returned for in the post column, we're actually going to I have some weird ordering here. Look at the user, kind of the type. And so this is a relationship on the user type. And so what we're going to do is reload the user type, basically do a find unique query with Prisma, and then include the post type and kind of automatically issue that, basically, and do a select, and then pass in this where clause along with the pagination information. And then once that resolves, it will automatically return things. And this kind of serves as a fallback for a number of different cases. The kind of collision case where you have multiple relations for the same thing is pretty uncommon, but the same pattern also applies if, for example, you forget to spread that query object in and don't actually issue the query that has those fields pre-selected, or there's a couple of other kind of edge casey things. The overwhelming majority of the time this doesn't happen, but the Pothos plugin tries very hard to make sure that all of these cases are supported. These queries also end up being very efficient for a number of reasons. So we have, we query using find unique on the parent object, which allows us to resolve multiple relationships with one request. And then Prisma also has an optimization when you use find unique that allows you to automatically batch multiple queries for multiple users into one request. So if we're in like an n+1 type of situation where we had a list of users and we're trying to resolve all of their posts, those will automatically get batched into one thing. And there's a number of other optimizations here I don't have time to go into, unfortunately, but hopefully that gives kind of a rough overview of how some of this works. I've got I'm running out of time here, so I'm going to go through this very quickly, but there's some of the cool features I want to just mention briefly. When you're defining an object type, you can define an include on that, and automatically when you define a resolver, you'll have access to those fields that you're including on the object type. Let's see, we've got, you can do something similar rather than defining stuff for a specific object type. You can basically have selections that only get added in when that specific field is queried by the user. So here we have a profile bio that we want to expose directly on our user type, but it goes through kind of a nested selection. So this is a field that does a select of that bio field, and then types this in an entirely type-safe way, gives you access to that user profile bio field that you selected above. And then finally, there's a select mode. So by default, when you define a type, it just loads all of the columns for whatever type you're loading. But you can also put it into a select mode by defining like a default set of fields you want to select. Here, we're just using an empty selection. And then you can expose whatever fields, even if they're not part of that selection. But then if you define a field that has like its own resolver, you just specify the fields you want to select to be able to resolve that field. And then it will let you do that. Basically give you a resolver that can resolve those fields. And all of this is kind of type safe, and those selections automatically get merged together into that same single query. Let's see, there's also relay nodes, which I didn't get a chance to mention. Variance allows you to find multiple types based on the same model in your database, so you can do that. You can add counts on relations and connections. I'm just going to skip over that because it's too... and then, oh yeah, composite types are something that I haven't had time to support yet, so all of you who are excited about the new Mongo features, I'm going to be supporting composite types in Pothos as well soon, but I haven't gotten around to it. And adding some new features for input types, filtering, sorting, better docs, and some helpers to make some basic CRUD stuff more easy. Currently, it's a little bit complicated. There's a lot of manual stuff you have to do to set up a CRUD type API, and I don't think generation is generally a good solution, but this might be helpful for people building quick prototypes and things. And I think that's the end of my slides. So if anyone has any questions.